Hello, and welcome back to a video series on MAC 1105 College Algebra. My name's Sean Perry. This is Guided Notes number 2 on Section 2.2, Models and Applications. So this is going to be a Guided Notes series where we work on word problems. Before we begin that, I'd like to just give my sort of 2 cents on the correct algorithm for approaching word problems. Now, the most important step is perhaps the 0th one. We're going to want to read the problem. After we read the problem thoroughly, we want to start to break it up into some logical pieces. At this point, I might try to draw a picture, and I might want to identify key objects and subjects in the problem. So what is the problem about? These objects or people are going to get special names. So let's not just identify them, but identify and name key objects and subjects. And we're going to want to give those names some short one-letter variable names. Then we're going to want to write down facts about these objects or subjects as equations. We're going to take whatever information we're given in the problem and use our new names for the subjects or objects to write down facts in equation form so that we can solve those equations for the desired variables. So as we go through each one of these, maybe we won't need a picture for every single one, but for each one, we're going to read it, identify what are the pieces and important nouns from it. We're going to write down the facts that were given in that as problem as equations, and then we're going to try to solve those equations for the given variables. Question number 1 says 59 people showed up to the party. There were 9 less men than women present. How many women were there? So we'll assume the gender binary for these problems because that's going to be a tacit assumption and for no other reason. I think we can skip a picture for this problem, but let's identify the key players. There are 9, actually this should be fewer, let's use proper grammar here, 9 fewer men than women present. Less is for magnitude, fewer is for count. So we know that there are, however, men and women at this party. We assume no NBs, and we say then that there are M and U's that I'm concerned about. These are the subjects of the problem. Now let's go into writing facts about those subjects. There are 59 total people. The implication is that there is a total number of people given as 59. Well, the total number would be summing the total number of men plus the total number of women. Now we need one more particular fact. It says there were 9 fewer men than women. So in other words, if we had the total number of women and we went down by 9, we would have the number of men. So in other words, women minus 9 is going to be equal to the number of men. These are the 2 facts we need to solve this. How do we solve it? Well, we have 2 variables and 2 unknowns. When that's the situation, what we could do is solve for one of those variables. And in fact, in the second equation, that's already done. It's already solved for the number of men. And now we take advantage of a property called substitution. Substitution is a deep axiom of math. It says that if 2 things are equal, they can be interchanged. In other words, if I know this m is equal to w minus 9, then wherever I see another m, I can replace it with w minus 9. So writing the first equation, but instead of writing m, writing w minus 9, I get a new equation. I get that w minus 9 plus w is equal to 59. Now this has actually improved our situation somewhat because now we only have one variable. We have w plus w, that's 2w, minus 9 is equal to 59. And adding 9 to both sides, we get 68. And dividing by 2, we get the number of women, which is 34. Now, we can then go back into our second equation, w minus 9 equals m, and say that means that 34, again, we're substituting because we now know what w is equal to, so we can replace w with 34 and subtract 9 to get the number of men, which is going to be 25. So we now have that m is equal to 25 and w is equal to 34. This answers the question. Number 2 says, Amanda rented a bike from Ted's Bikes. It cost $9 for a helmet plus $5.25 per hour. If Amanda paid $48.38, how many hours did she rent the bike? So it even gives us a little guidance here. It says, let h be the number of hours she rented the bike. Write an equation for how you would solve this problem, right? Well, first we need to know what is the total cost, right? How do we calculate total cost and what goes into it? So reading through again, we have a fixed cost, $9 for the helmet. And then we have a variable cost, $5.25 per hour. So focusing on the per here, right? This for each hour, she pays $5.25. So the total variable cost, the total for the hourly charge, is going to be $5.25 times the number of hours. If each hour we pay $5.25, then $5.25. So first of all, what were our objects of this? We have H, the hours rented. Then the total cost is going to be equal to $9 fixed. Always costs her $9 because she has to rent the helmet, plus $5.25 for each hour. So to get the total cost for the hourly rental, we have to multiply by the number of hours. So here would be an equation that we could use to get the total cost. $9 plus $5.25 times H. To solve this, right, we plug in the remaining piece of information that actually she spent $48.38, and we are going to solve now for H. This is the question. How many hours did she rent the bike for, right? Well, all we have to do now is solve for H. We minus 9 from both sides. 48 minus 9 is 39. So this is 39.38 is equal to 5.25 times H. And then dividing, I'll indulge in a little calculator use here. 39.38 divided by, right, because we're going to solve this, we're going to divide both sides by 5.25, and that's going to give me H. So divided by 5.25, we get this decimal. And rounding to the correct number of, well, we have sort of this extra tail term here, but it's pretty obvious that they're looking for these first couple digits, right? This is 7.5 hours and then some fractional change, some number of seconds, right? And that's because this doesn't cleanly divide. This wasn't an exactly generated problem. So what we're going to do is we're going to round prudently and say that this is approximately 7.5 hours. In fact, it even gives us a nice guidance here. Round your answer to the 10th of the hour, so that's what we did. Number 3 says, Aisha is asked about her age, and she answers, my age is 10 more than 5 times the age of my grandson. You ask an old person a question, you're going to get a riddle. All right, so let's figure out this riddle. How old is her grandson if she is 60 years old? Notice that unless we knew the age of her grandson, we couldn't figure out her age, and vice versa. But now that they've given us this extra piece of information, can we figure that out? The answer is yes. So first of all, we want to identify that there's these two important variables here. We have Aisha's age, and we have her grandson's age. Let's call Aisha A, and let's say her grandson is G. So now we want to write down the fact given in terms of these two variables. Aisha's age, A, is 10 more than 5 times the age of her grandson. And now they've sort of given us the extra fact that Aisha is 60 years old. So can we solve 60 equals 10 plus 5g? Well, certainly. We're going to minus 10 from both sides and get 50 equals 5g. And dividing by 5 on both sides, we get that g is equal to 10. No sweat. Suppose the average salary of someone whose terminal degree is a master's is $44,000 less than twice that of someone whose terminal degree is a bachelor's. Combined, the two people with these terminal degrees earn $130,000 on average per year. Find the average yearly salary of the individual with each of these terminal degrees. Okay, so let's sum up these long phrases. Average yearly salary of someone whose terminal degree is a master's. Let's call that something, something, something. Someone whose terminal degree is a bachelor's. Let's call that B. And if those are our two players, what's the fact that ties them together? It says that the average yearly salary of someone whose terminal degree is a master's is $44,000 less than twice that. Okay, so master's is $44,000 less, that's subtracting $44,000 from twice that of someone with a bachelor's. So twice the bachelor's minus 44. And then they tell us some more. They say combined, these people have 130,000. In other words, if I have M plus B, master's yearly average plus bachelor's yearly average, I get 130,000. Let's just write these numbers in terms of thousands so we don't have to write 44,000 here or 130,000. But you could write thousands here and that would be fine. But let's just assume that the units we're working with are not dollars, but thousands of dollars. in which case we can just leave this as 44 and 130. Now, to solve this, what we're going to do is we're going to take advantage of the fact that this has already been solved for m. That means that anywhere I see another m, I can replace that with 2b minus 44. So if I do that in this equation here, if I write 2b minus 44 instead of m, then I have b added to that gives me 130. Now this can be solved. We add the b's together and get 3b minus 44 equals 130. And adding the 44 to both sides, we wind up with 3b is equal to 174. Does 3 go into 174? It surely does. 174 divided by 3, putting this in 5 times, right? We get 15. Taking the difference, we get 24, and that goes in 8 times. So dividing both sides by 3, we wind up with b being equal to 58. Let's go back to one of these equations. Let's say m is equal to 2b minus 44. And if we substitute this in, we have 2 times 58 minus 44 is equal to m. 2 times 58 is going to be 116. Minus 44 is going to be, let's see, 112. So that's a little bit easier if we write it vertically. That's a 2. 4 from 11 is 7. So that's going to be 72, and that's our answer. We could also have taken it and substituted it back into this equation and solved for m. It really doesn't matter. We'd get the same answer either way. Number 5 says, after a 60% reduction, you purchase a new television for $217. What was the original price? Round your solution to the nearest cent. All right, so we know a little bit about price here and how sales works, right? If I want to get this price of a television, let's say that we have the sale price S and the original price P. These are our two main players here in this equation. How do I get S from P? Well, you're going to have P, the original price, minus a certain percentage. In this case, 60%, but let's write 60% as a decimal instead. So that's moving the decimal place twice, and we get 0.6 times P. This is how you get the sale price. You take the original price and minus a percentage of that original price. Don't forget to multiply by the original price again. Now, if you like, you could combine like terms here and say this is 0.4p. 1p minus 0.6p is 1 minus 0.6 or 0.4p. So that's all well and good. Either way you want to do that, we're either going to be, doing this now or later. I say we do it now. Okay, so very good, but what were the particular pieces of information that they gave us in this problem? They said that the sale price was $217. Okay, this is our S. It was $217. And they want to know what was P. Okay, well, if this is $217, we want to solve for P. I'm going to need to divide by 0.4 on both sides. And again, this isn't too hard to actually do the division. What is 217 divided by 0.4? Just move this decimal over 1 and divide. Goes into 21 5 times. 17 goes in 4 times. 10 goes in twice and goes into 25 times. So we have 542.5. 542.50. Let's round it to the cent, and that's equal to P. Now, we could check our work. Of course, we could check our work on a calculator. What is 217 divided by 0.4? And there we have it. Including a 9% sales tax, a hotel charges this much per night. So including the tax, okay? So what was the original price? That's going to be the question. Find the hotel's rate before the tax was included. Again, now we have to know something about how tax works, right? If I have some original, let's call this tax. If I have some original price or rate, let's call it, right? Then they're going to charge me this much. Let's call that C. How do I arrange these facts together? Well, you're going to have C is equal to the rate plus, we're going to add to that some tax, which is going to be the tax amount times the original rate, right? It's 9% of something, right? 9% of what? 9% of the original amount of money that you would spend. And as such, when you're doing these sort of tax problems, again, combining like terms, we're going to have 1 plus that tax rate up front. let's plug in the numbers that they actually gave us here, right? They told us that this was $196.5, and this was equal to a 9% tax rate. All right, well, that's going to give us 1.09 here, because 9% is equal to 0.09 as a decimal, times the original R, the rate per night. So how do I solve for that? Quite simple. You just divide on both sides by 1.09. This would be no different than if we had just called this 0.09. If I had at the beginning said this is R plus 0.09 times, we still would have needed to have added 1 and 0.09 to get 1.09 times. So taking 196.5, dividing that by 1.09, we will get our original rate. So let's bring up our calculators, because I don't want to do 3-digit division. What am I, a masochist? Divided by 1.09, this is what calculators were made for. Not to take away our thinking, but to focus on what the meaning of the answer is. In this case, I get 180.275. Let's round that to the nearest cent, 180.28. And this amount is the total rate that the hotel would charge, plus tax would give me 196.5. or $196.50. The price of a new refrigerator is $1,060.12 if the markup is 18% of the wholesale cost, meaning that in order to get this price, they added 18% to the amount that the store bought the refrigerator for. So the store buys the refrigerator for the wholesale price, and then they sell it to you at the marked up price. If the markup was 18%, what is the wholesale cost of the refrigerator to the refrigerator dealer? Well, let's find out. So how do you get a marked up price? Okay, so I buy it for a certain wholesale cost. Let's call that C. And now we have this price that we're going to charge the client for that. Let's call that P. How do I get that if the markup is 18%? Well, we're going to get P by taking the cost C and adding to that 18% or 0.18 times C. Very similar to the tax added equation. This is, of course, 1.18 C. And so if I want to solve for C, I'm going to divide by 1.18. So we were told, however, this has got some particulars to it, right? What is P? P was given as 106012. And so in order to solve for C, I want to divide both sides by 1.18, and we get that C is equal to, grabbing our handy dandy calculator, 1060.12 divided by 1.18. And rounding to the nearest cent, that's 898.41. 898.41. And there you have it. They bought it for $198.41 from the wholesaler, marked it up by 18% or added 18% of that to that cost, and that's the price that they would now charge the consumer, taking from that gain, taking from now the surplus value, something to pay for the cost of having a dealership or employing refrigerator or appliance sales personnel. Number 8 says, Maya put X dollars into an investment with an interest rate of 5% per year, and Y dollars into an investment with an interest rate of 11% per year. She invests a total of $3,800, and her interest earnings after 1 year are $340. From this, we're going to create some equations and solve the system. So let's dive on in. But first, we have to know how simple interest works. The total investment, the total amount that she invests, is the amount that she puts in one account plus the amount that she puts in the other account. They've even named our variables for us, X and Y. And they said that this total amount she invests was $3,800. Now, the interest that she earns, so you need to know a little bit about interest here, right? How does that work? Well, the interest that you're going to earn, say, from X is going to be the percentage value, 5% or 0.05, times X itself. And the interest earned from Y is going to be likewise 11% times the total quantity that you put in Y. It's 11% of Y. And what is our total interest? It's the sum of those two partial interests. So sort of taking out these intermediary variables and putting it together, what is your total interest? It's going to be 0.05x, 5% of X, plus 11% of Y. Now, we were told the amount of interest that she received. She received $340 worth of interest. So we also know that this equation is going to give us 340. And now we have to solve this coupled system. The way we should go about it is first solving one of the equations where it's easy to do so for one of the variables. Notice to get x here, all I have to do is minus y to the other side, and that's 3,800 minus y. Once we've solved for one of these variables, I can go and plug it in wherever I see that variable to give me 0.05 times 3,800 minus y plus 0.11 y is equal to 340. Distributing my 0.05, I have 3,800 times 0.05. This gives me 190. So we have 190 minus 0.05y plus 0.11y is equal to 340. Now, minus 0.05y plus 0.11y is 0.06y, 340. And 190 out front, how do I get rid of that? I'm going to need to subtract by 190. And borrowing here, we have 150. And that is equal to 0.06y. If I then divide by 0.06, 50 divided by 0.06 gives me 2,500. So this gives me y equals 2,500. And now we can go back to our equation for x right here, and we can say that x was 3,800 minus y, which we now know is 2,500. And this, of course, gives us 1,300, and that is the amount for 5%, while 2,500 was the amount invested at 11%. Now, number 9 says the length of a rectangular field is 18 yards longer than triple the width. If the perimeter of the field is 660 yards, what is the field's length and width? I think this is a perfectly fine one to break out a picture, because we know what a rectangle looks like. Here's a rectangle. Rectangles have a certain length and a certain width, but they also have the exact same length and width opposite those. And so what is the perimeter, or the length around the rectangle? It's going to be L plus W plus L plus W. It's 2 L's plus 2 W's. Likewise, they told us that the length is 18 yards more than triple the width. So we have the following equation to unite length and width. Since this is solved for length, we can now say that the perimeter is also equal to 2 times 18 plus 3W, now substituting L for L, plus 2W. And this, in turn, they told us was 660 yards. So let's solve this equation. We have 2 times 18, that's 36, plus 2 times 3, that's 6W, plus 2W is equal to 660. If we minus 36 from the other side, we'll get a 4 here, and then 5, so minus 30, that's a 2, so 624. And then here, combining like terms, that's an 8. Does 8 go into 624? I don't know. Let's find out. 8 into 624. Well, 8 certainly goes into 60. It goes in 7 times to give me 56 here. And then subtracting this, I get 64. Goes in 8 times evenly. So we have dividing by 8, we have that W is equal to 78. And then going back to my equation for L, we have 18 plus 3 times 78. 78 times 3 is going to be 210 plus 24, so that's 234. And adding 18 to that, we have a 2, carry the 1, 4 plus 1 is 5, and a 2. So 252. And we could check our work here, because we know, first of all, we should get 252 times 2 plus 78 times 2 is equal to 660. Is, in fact, 252 times 2 plus 78 times 2 equal to 660? It is. Moving on, we have a hotel that costs $65 the first night and $61 each night thereafter. How many nights did we stay at the hotel if the total bill was $675? So let's write down the total bill. The equation for that would be $65 plus $61 times the number of additional nights. Let's call that N. So if this was $675, how many additional nights did we stay? Well, this is 65 plus 61n. Subtracting 65 over from here, I'm going to have 610, and that's 61n. Dividing by 61, hey, we're in luck, that's just 10. So this is the number of additional nights we spent. How many total nights did we spend? Well, we spent one night plus 10 more nights, so 11 total nights. Don't forget to add that first night. Okay, here we have some literal equations that we're going to want to solve for. The main idea here is that we're going to want to solve for variables that might be in the denominator or hidden behind a power. Let's see how we do that. So the first thing that we want to do, if we notice that we have a fraction and our variable is sort of tucked away in the bottom, is we want to multiply on both sides by that denominator. If I do that, it has the effect of killing the fractions that are involved, and instead just leaving us, some terms that have multiplication only in them. That is to say, these cancel, and we wind up with r plus nr times I is equal to ne. Now I'm going to want to solve this for big R. I'm going to need to, first of all, get rid of this I. We could distribute it and then divide it over, or we could divide it over right now. There's actually a couple different ways we could approach this. If I do it this way, I'm going to wind up with this expression. And then in order to solve for r, I'm going to want to subtract nr over. When I do that, I just need to rewrite things. We have r equals ne over I minus nr. Like I said, there's a variety of different ways this could look. This is just one possible answer. We could also combine these two fractions and get something else. I'll just leave it like this. Okay, so moving on, we have another one where we have our variable hidden in the denominator. It's not going to be a problem. What I need to do is multiply on both sides by m times t1 minus t2. I do that on one side, then I must do it on the other side for balance. When the dust settles on that, we wind up canceling the denominators here and getting m times t1 minus t2 times s equal to h. To solve for m, I just need to divide away what's multiplying by m here. And what's multiplying by m is t1 minus t2 times s. We need to do that again on both sides, or else we haven't been balanced. And when I do that, we wind up with m alone, because all this cancels here, equal to h over t1 minus t2 times s, all of that in the denominator of h. So moving on to question 13, the way that we solve for r is by taking the square root of both sides once we've isolated the square. So to isolate the square, we first want to divide by p on both sides to get a over p is equal to r squared. To get rid of a square, we take the square root of both sides. So the square root here, the square root here, square roots and squares cancel each other somewhat, and we wind up with a over p. Square rooted is equal to r. I say somewhat because truly, if you take something like minus 2 and square it, and then square root it, you wind up with the square root of 4, which is 2, and you don't wind up with what you started with at all. But that's why they told us that all of the things involved were positive. Likewise, normally when we take something like, I don't know, 4 is equal to r squared, and we want to take the square root of both sides, we're going to need to take into account that both plus and minus 2 could work here, because minus 2 squared would be 4. But again, we don't actually have to worry about putting a plus and minus in front of this term because they told us already that r is positive. So we can leave it just like this. Some of you who go through, other means of solving your problems, like chegging it, or if you just know about this yourself and you know to rationalize denominators, might get a slightly different answer, which is nonetheless correct. The square root of a over p is the square root of a over the square root of p. That's distribution of the radical. If you multiply that by square root of p over square root of p, which is a fancy version of 1, what you wind up with is the square root of a times the square root of p over the square root of p squared, which is just p. And then bring that under a common radical, you have ap over p. So these are actually completely equivalent, and there's no reason to favor one over the other. I think this one is a little bit nicer because it uses fewer symbols, but we'll learn when we talk about rationalizing denominators why this one might also be preferred. Now, I've noticed that the online homework doesn't seem to want to accept this answer, which is problematic because it's also correct. So you're probably going to want to put in this answer instead, but I will try to fix that as soon as I can. All right, what about this one? We want to solve for this w. So the first thing we want to do is get rid of the sort of easier terms. We have a 2L here, which I think I'll use this L for it. And we want to minus that from both sides because it's being added to w, that'll get rid of it. So this is p minus 2L. If I then take and divide by the 2, we wind up with the following expression for w. We get w is equal to p minus 2L over 2. Now you could distribute the 2, but only to both terms. That would give you p over 2, but would cancel in this to give you L. And this is what we would have gotten if we had solved it a different way. If we had taken p is equal to 2L minus 2w, and we had started by factoring out the 2, plus 2w. If we had started by factoring out the 2, we could have started by dividing that from both sides to get p over 2 is equal to L plus w, and then subtracting L. This would give us our p over 2 minus L is equal to w. So really both of those are equivalent expressions. Both are perfectly good ways of solving this problem. Finally, we have this nice question here. It says, the sum of 3 consecutive natural numbers is 492. Natural numbers are positive, whole numbers, and 0. So how do I write 3 consecutive natural numbers? Consecutive means one after another, like 3, 4, 5, or 678, 679, and 680. These would be examples of 3 consecutive natural numbers. Okay, so what we need is an expression for those natural numbers. Let's say x was our first one. Then the next consecutive number, whole number, would be x plus 1. And the next consecutive number would be x plus 2. And they say that the sum of these, x plus 1 plus x plus 2, was equal to 492. But adding up all these things, we have 3 x's, plus 1 plus 2, that's 3 as well. And now we just need to solve what is 3x plus 3 equal to 492. Minusing 3, we have 489 is equal to 3x. And taking 489 and dividing it by 3, divide by 3, what's this x going to be? So that's going to be 1, 6, and 3 with no remainder. So this is 163. And so what are our 3 consecutive numbers? They're going to be 163, 164, and 165, respectively. All right, that's going to be it for this particular video. Thank you very much for your patience and have a great day. Good luck with your studies. I'll see you in the next one.